Okay, so we're going to go over permutations. This is essentially our formula. The number of permutations is the number of total options, so that's our n, how many total options there are, divided by the amount of essentially redundancies. Okay, and there could be more than one. A would be representing the first redundancy, B, C, and so on. You could have many different redundancies. So let's talk about mathematics. You can arrange the letters in mathematics many, many different times. And in order to figure out the amount, we need to figure out how many letters there are. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What do we have here? Is it 11 or 10? Did I count that wrong? Oh, 11. Sorry. There are 11. So there's 11 letters here. So essentially, if there were no redundancies, we'd be looking at our permutation being 11 exclamation mark, essentially, right? And what that really represents is just 11 times 10 times 9 times 8, all the way down to, to 1, not 7. 5, and then dot, 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 all the way down to 1. We multiply all those numbers together, and that tells how many there are. But we have redundancies, like we said. For instance, there are a pair of A's, there are a pair of M's, there are a pair of T's. Okay? Anything else? No, everything else is the same. So this formula actually goes like this. 11 being our n, the total number there are. So we have 11 permutation divided by, now each of these are a pair. Okay, so because they're a pair, we always use the number 2. There are 2 A's, so we divide by permutation 2. That represents our A's. There are 2 T's, permutation 2, and there are 2 M's, permutation 2. Okay, so this would be the formula to figure out how many there are. Okay, and again, the first 2 represents the A's, the second 2 represents the M's, and the third 2 represented the T's. Okay, now in this question, they just wanted to know what the indistinguishable items are. Well, we know they're M, A, and T. But we can actually solve this question. We'll go about solving it. Now, I don't know if this calculator I have has that on it, permutations. Oh, it does. Okay, perfect. Let's clear that. So, if I were to say permutation of 3, that would just be 3 times 2 times 1. So let's just double check. So it tells us that's 6. Perfect. Okay, well in this one, what we're going to end up getting, let's clear that, we do permutation of 11, so we get a very large number, 399168800. Let's try to remember that. I'm definitely not going to remember that. Okay, I'll do half, you do half. I'm going to remember 3991, and you do 6800, okay? 3991, what was it?
6800.
Okay, good. So that's our top one. And then in our bottom one, we have 3 permutations multiplied by each other. Well, technically, these are essentially just 1 times 2. For instance, let's do one of the 2's. Permutation of 2 is just 2. Permutation of 2 is 2. And permutation of 2 is 2. So they're all, essentially all that says is 2 times 2 times 2. Okay, that's going to give us our 8 in the end there at the bottom. And then we just have to divide those numbers to figure out what our total number of permutations are. So 399168800 divided by 8. It's 4989600. 4989600. 9600. Does this make sense so far?
Yeah.
Okay, so along with that, what I'm going to do is I'm going to actually break down this question here to show you how we can eliminate some things. So, because that 11 essentially stands for P is equal to 11 times 10 times, we're going to write them all out, okay? You will always work all the way down to 1. That's what it's saying. Okay, so that's what the top of this equation was essentially saying. 11 times all of those terms. And then at the bottom, each permutation, so we'll do them in different colors. We'll actually do this one in purple so it's a little easier to say. Essentially just said 1 times 1, that represented the first one, multiplied by, sorry, not 1 times 1, 2 times 1, multiplied by 2 times 1, okay? Well, in terms of factoring, because this is all multiplication, I want you to notice that we have a set of 2 times 1, and we have another set of 2 times 1. If I didn't have a calculator and I need to do this by hand, this and this could cancel each other out. And we'd actually only need to go from 11 to 3 divided by 2 times 1 times 2 times 1. We could kind of drop these two off. It doesn't matter because we have calculators, we can work it all out the long way. But just as a side note, that's what essentially this could be written as. Okay, so there's permutations when we have redundancies.